Good day to you, Sir Alvin. My name is James Christopher C. Esteban of CS2-1, and I am here to discuss to you on how I got my answer for my binary search tree of my name with unique letters. So the first thing that I'm going to do is that I'm going to write my name with the unique letters. So my first name is James, which has unique letters JAMES. Then my second name, which is Christopher, which is spelled as CHRI. Since S is already given from the James, I'm going to skip that. Then I'm going next to the next. I'm going next, which is T. Then O. The letter P. H is already given from here at the first part of Christopher, so I'm going to skip that, as well as E and R. So going next is for my last name, which is Esteban. E is already given, as well as S and T, then letter E again, so I'm going to skip those letters. The next letter is B, which is not yet given. A is already given from James, so I'm going to skip that. Then I'm going next to the last letter, which is N. Now for the next step, I'm going to set letter J as the root of the tree. So J will be sitting here on the top. Next is we're going to compare the letter A to letter J. Since A comes first, A is less than J. So we're going to put A as the left child of J. Going to the next letter is letter M. So comparing letter M to letter J, M goes after letter J. So we're going to put M on the right child of J because M is greater than J. Next letter that we're going to compare to the root is letter E. E is less than J, but since letter A is already sitting as the left child of J, so we're going to compare E to letter A. A is great E is greater than A, so we're going to put letter E as the right child of A. Next letter is S. S is greater than J, but since M is already sitting at the right child of J, so we're going to compare letter S with letter M. Letter S is greater than M, so we're going to put S as the right child of M. Next one is letter C. C is less than A. C is less than J, so we're going to put it at the left child of J, which is occupied by letter A already. And since C is greater than A, we're going to put it on the right child of A. But since it is already occupied as well with letter E, we're going to compare C with letter E. So since C came first before E, we're going to put it as the left child of E. Next letter is H. So H is less than J. So we're going to put it on the left child of A. Comparing H to A, H is greater than A, so we're going to put it on the right child of A. But since E is already sitting at the right child of A, we're going to compare H to E. Knowing that H is greater than A, we're going to put H as the right child of E. So, the next step is compare R to the root. R is greater than J as well as M. So, we're going to compare it with letter S. R is less than S. So, we're going to put it on the left child of S. Next letter is letter I. Comparing I to J, I is less than J. A is already sitting at the left child of J, so we're going to compare it. I is greater than A, So we're going to put it on the right child of A. But since E is already sitting there, we're going to compare it here. I is greater than E, so it's going to the right child of E. But since H is already there, we're going to compare it with I. So I compared to H, I is greater than H, so I will be the right child of H. The next letter is letter T. Comparing T to the root, which is J. T is greater than J, so it's going to the right side, right child of J. T is greater than M, so it's going to the right child of M, but it is already occupied by S, so we're going to compare it with S. T compared to S, T is greater than S, so it will be the right child of S. Next letter is letter O. O is greater than J, but as I said earlier, the right child of J is already occupied with M. O is also greater than M, so it's going to occupy the right child of M, which is occupied by S. So compared to S, O is less than S. So it is going to the left side, left child of S, which is R. We're going to compare O to letter R. So knowing that O comes first before R, so it's less than R. So it's going to be the left child of R. Next letter is letter P. P is greater than J. So it's going to the right child, which is occupied by M. P is greater than M, so it's going to the right side as well. So S is greater than P, so P will be going here on the left child of S, which is occupied by R. P is also less than R, so it's going to the left side as well. P compared to O is P will be greater than O because P comes after O. So it's going to be the right child of O. Next letter is B. B is less than J, so it's going to the left child of J, which is occupied by A. B compared to A is greater than A, so it's going to the right child of A, which is occupied by E. B compared to E is less than B. E compared to B is less than, so it is going to the left side of B. B compared to C, B is less than C, so it's going to the left child of C. So for the last letter, N. N is greater than J, so it's going to the right child of J, which is occupied by M. N compared to M is the N is greater than N, so it's going to the right child of M. Since it is occupied by S, we're going to compare N to S. N is less than S, so it's going to the left child of S, which is occupied by R. N compared to R is less than, so it is going to the left child as well. So N compared to O, N comes first before O, so it's going to be the left child of O. So this is the binary search tree of my name with the unique letters.